Hi there, and welcome to this lesson on Pure Mathematics 1. And in this lesson, we're looking at the special case of the sine rule. Now, the special case of the sine rule, it's sometimes called the ambiguous case. And the reason for that is you're given information about a triangle, and it looks like it's enough information to define the triangle exactly, but it isn't. What you're given is slightly ambiguous, and there are two possible triangles that you could draw given the information you're given. Now, the easiest way to see this is if we look at an example. So let's say you had the triangle ABC, where AB is 5, BC is 3, and angle A is 34 degrees. There are two different triangles that both have these properties. And the first of those would be this triangle, where AB is 5, BC is 3, and angle A is 34 degrees. But that isn't the only triangle that you could draw with these properties. If you imagine drawing BC last of all and doing a standard construction using a compass, and you put the point of the compass on B, set it to 3 centimeters in length, then you'd be doing a sketch around here, drawing an arc. That arc would go around and then come back again and cross the side a second time. What that means is the triangle could look like this, or it could look like that. And AB is 5, BC is still 3, and angle A is 34 degrees. So that's the first possibility, but that's the second possibility with the information we've been given. So that's showing both possibilities together. Now, this doesn't happen all the time, but it can happen when you're given two lengths and the angle you're given is not the included one. So it's not angle B. If you were given angle B, then the triangle would definitely be well defined. But if you're given two lengths and an angle which is not where those two lines meet, then you can get the ambiguous case. Now, if you do, it's this angle here at C that becomes the problem. So the first possibility is that's the size of the angle. It's clearly acute. The second possibility is you have a very different angle, which is clearly obtuse. Now, if we call this angle theta, you'll notice that this is an isosceles triangle because both these lengths have to be 3. So that means this angle down here would also be theta, which means the other possibility for angle C will be 180 minus theta, which is what we've written here. So when you use the sine rule, it could be that angle C is the answer you get using your calculator, whatever theta is, or it could be 180 minus that. Now, you do need to remember that, and there'll be some questions where you have to write down both possible answers. It's easy to do as long as you remember. The first possibility is the answer your calculator gives you, and that would give you that possibility. The second possibility is you'd have to do 180 take away the answer that your calculator gives you. And that would be for this possibility. Okay, well, we'll go through this example itself and see how that works out in practice. So I'll let you have a go at doing this. Given triangle ABC with the conditions that we just gave, there are two different triangles that have these properties, as we just saw. Find both possible values for the size of angle C. So you use the sine rule as normal, use your calculator as normal, get the first answer, that's one possibility, then do 180 take away that, that's the second possibility. Pause the video, have a go, and come back to me when you're ready. Okay, let's have a look at this. So as we said, that's the first possibility. Using the sine rule, we'd have A over sine A, or sine A over A, because it's the angle that we're trying to find, is equal to sine C divided by C. As always, there are 3 things we can substitute in. So sine 34 over 3 is equal to sine C divided by 5. Rearranging that gives us sine C is 5 sine 34 divided by 3, which gives us 0.9319. Now that's the sine of C. So we need to do inverse sine. And inverse sine of that will give us the first possibility, that C is 68.7 degrees. But then we need to remember that there's a second possibility, that there's a second triangle that you could get And for that triangle, you'd need to do 180 take away 68.7. That gives us the second possibility for C, which would be this angle here, which is 111.3 degrees. Okay, that gets us to the end of this lesson. If you've got the textbook, then turn to page 115 and have a go at exercise 6C. Thank you very much for listening, and cheerio.